My name is José Henrique Marques. I am a PhD student at the Institute of Chemistry of São Paulo State University, under Leandro Martins' supervision. I will present my research project called Modification of SSZ-13 as a strategy to improve performance and minimize the activation by coke in MTO reaction. Methanol can be obtained from several sources, such as natural gas, coal, and renewable sources such as biomass. Several products made today from non-renewable sources can be produced from methanol. Starting from methanol and using a catalyst called zeolite, we can produce several products, among them light olefins such as ethene and propene. Zeolites are microporous materials composed mainly of aluminum, silicon, and oxygen, and have cavities capable of distinguishing the products that enter, remain, and leave their cavities. When replacing a silicon atom in its structure with an aluminum atom, its structure acquires a negative charge. This negative charge can be balanced by a proton, giving acidity to the material. And it is in these acid sites that the reaction occurs. Zeolite with Chabazite structure are great for production ethene and propene, as they have large cavities with small openings that do not allow very large hydrocarbons to escape. Ethene and propene are widely used in the plastic production. For example, PVC and polyethylene can be produced from ethene. With propene, polypropylene can produce. The mechanisms identified as responsible for the formation of reaction products is the hydrocarbon pool mechanism, which consists of an autocatalyzed process that the substances formed in the initial stages of the reaction act as a catalytic platform for final products formation. The hydrocarbon pool mechanism would run for two cycles, one based on olefins and the other on aromatics. These two being concurrent and interrelated cycles through hydrogen transfer and cyclization reaction. As the reaction progresses, highly unsaturated and reactive compounds are formed, which end up deactivating the catalyst. Formaldehyde is a substance that has been identified as playing a crucial role in the reaction of formation of polyunsaturated compounds. Formaldehyde reacts with alkenes to form a substance with an extra unsaturation as a product. Yttrium oxide can selectively decompose formaldehyde and thus can contribute to decrease the deactivation of the catalyst by highly unsaturated compounds, called coke. This study's main idea is to enhance the performance of SSZ-13 catalysts to MTO reaction by the impregnation of a mesoporous SSZ-13 catalyst with yttrium oxide. So far, I have already prepared a catalyst for the reaction of methanol to olefins by mixing SSZ-13 zeolite with yttrium nitrate in solid state and calcination at high temperatures. This graph shows us the yield and function of time of the catalyst prepared for the reaction of olefins production from methanol. When preparing a catalyst with a ratio of 0.1 between the yttrium atoms and the aluminum atoms, we obtain a higher ethene and propene yield than zeolite, which did not undergo the impregnation process. However, when using a ratio of 0.2, the behavior did not follow an improvement trend. This study is at initial stages, but we believe it can provide us valuable information for understanding methanol to olefins reactions.